This conference will now be recorded.
Very good evening, students. So far we have discussed LCR circuits and LR circuit, CR circuit, and individually we have discussed purely inductive, resistive, and capacitive circuit as well. We have discussed what is electrical power, AC power, and we had discussed power factor, etc. So today we are going to take few numerical examples from previous year's JEE papers. So this is a question. So let us start our sessions today. So this is a question in a LCR circuit. I'll just draw the circuit here over here. So this is the resistor. This is the battery. This is actually a DC battery. So when we go for solving numerical problems on AC, we have seen not only AC, even with DC also this LCR circuits, etc. There could be questions from there. Okay, like this question is not. See, the battery is not an AC battery. This or AC source. This is actually a DC source. You see that. This is an inductor. Okay, so there are two switches as you see. This is one, this is S2, switch 2, and this is switch 1. Okay, so this is capacitor, this is inductor, and this is the resistor. Excuse me, so I had got a call. All right, so this is the circuit related to this question. Let us read the question. In an LCR circuit as shown below, both switches are open initially. Now switch S1 is closed. Okay, S1 is closed. S2 kept open. Okay, S2 kept open. Q is the charge in the capacitor. Okay, and T is RC, that is the tau. This is actually tau. This is called time constant. Time constant. Time constant. In a capacitive, this is a capacitive time constant. This is called capacitive time constant. Which of the following statement is correct? And see the statements. When t is equal to tau, what is the charge? Q is equal to Cv by 2. When t is equal to 2 tau, Q is equal to Cv whole into 1 minus e to the power minus 2. At t is equal to tau by 2, Q is equal to Cv whole into, I guess, yeah. All right. The last option is work done by the battery is half of the energy dissipated in the resistor. So what is correct here? So you can see when the S1 alone is closed and the other one is open, then effectively this circuit is becoming actually CR circuit. Okay, series RC or CR circuit you can say. So this circuit is becoming effectively like this. That means, you know, this is R and this is C. So actually you have to know the charging. This is actually charging of capacitor. This circuit is for charging of a capacitor. And I hope you know this, how to do this. And see, I have already discussed this RC circuit or charging of capacitor through like yeah, capacitor by DC battery. We have already discussed this. I just directly write. See what will happen. The charge will be accumulated in the capacitor, and that will actually that will be exponentially growing. Okay, that will be exponentially growing, and you know that the expression will be 1 minus t e to the power minus t by tau, where this tau is actually CR. Okay, tau is the capacitive time constant here as it is given. So this is the equation which you need to remember during charging. And during discharging, what will happen? It will be like this: Cp into e to the power minus t by tau. This is actually discharging, equation for discharging. This is discharging. While discharging, this is the equation, and while charging, this is the equation. So this is during charging. So we have been given a case of charging a capacitor, right? So look now. Look here. What is happening? If we see, the conditions are here. T is equal to tau. When t is equal to tau, so this term is becoming, let us do all these options. So I think I'll just erase some parts, okay, or let me just do it here, just related to this. Okay, so when t is equal to tau, expression for the charge will be seen to be 1 minus, see, this is tau, t in place of t, if I write tau, it will be actually minus 1. Minus 1 means 1 over e. Okay, it is for minus 1 means 1 over e. This will be the case. Okay, but here it is given something else, so it is wrong. Now at t is equal to 2 tau, Cv 1 minus 2 tau, and here tau. So tau goes up. Then what we get is this, e to the power minus 2. So this is actually the expression. Okay, see, it is actually truly given. Let us see whether there are multiple answers correct. I think this is JEE Mains paper and this section is not multiple answer correct. So this is probably the answer. Let us see the other options as well. So Q is equal to CV, say T by 2. If it is T by 2, then it will be e to the power minus half actually. Okay, so this option is not correct. The work done by the battery is half of the energy dissipated in the resistor. So in this case, you know, the work done by the battery is half of the energy dissipated. This is not true actually, because energy will be dissipated through both. So work done by the battery, actually this also will actually offer, see, I think is half of the energy dissipated in the resistor. No, it is not correct, because see, in case of C, since it is DC, since it is DC, after a long time current on flow. In other word, see, as long as it is getting charged, as long as it is getting charged, then also the work done, actually it has to do certain work for both actually. Okay, so because this electrical energy is getting stored in this also, right? So q square by 2c, so it is not true, actually it is not true. Okay, we'll go for that. So you have got the options, correct option here, so the second option is the correct here. We'll go to the next. So the next question, you look here the figure as well as the statement, and indicate, see, sorry, an inductor L is equal to 0.03 Henry. So this inductance is given, and then a resistor of resistance 0.015 kilo ohm are connected in series. That means this is actually an LR circuit. Okay, connected in series to a battery of 15 volt EMF in a circuit shown below. The K1 has been kept closed. So this has been kept closed. Okay, it has been kept closed all along. Okay, closed for a long time. I'm sorry, for a long time. So K1 is kept closed for a long time. Then at t is equal to 0, K1 is open and K2 is closed. So first what was there? This was closed for a long time, for a long time. Okay, for a long time. Then K2 is closed. Then K2 will be closed. Okay. So, like at t is equal to 0, K1 will be opened and K2 will be closed simultaneously. Okay, simultaneously that will be done. K1 will be open and K2 will be closed. The current in the circuit will be at t is equal to 1 millisecond. What will be the current? Okay, this is very simple. Very simple. This at long time, long time behavior will be, in case of inductor, what will be the long time behavior? Inductor will act as a, for at long time or long time behavior, at long time or longer time. In case of DC, actually in case of DC, because this is, this has fixed value, what will happen, when you switch on the battery, current in the circuit will actually grow from 0 to 5, sorry, voltage will grow or whatever current it goes. Okay, it passes. 15 volt will not be suddenly 15 volt, it will actually grow from certain value 0 to p volt. So since voltage will be changing across the circuit, the current also will change. During that time, whenever there is a change in the current, this inductor coil will actually offer some resistance. Okay, resistance to the flow of the current because of back EMF. But after long time, Okay, after long time, inductor will act as a conducting path. After long time, inductor acts as a conducting path. Conducting path. Okay. So this is very simple then. So what will happen? This will be a conducting path, this will be the resistor, and this will be voltage. So effectively after a long time, when the K1 is closed for a long time, I'll just draw the effective circuit, which is actually connected here, K1. And see what you have. You have just conducting path and this resistance. Okay. This is for long time behavior of inductor. Inductor will be a conducting path, and only in the circuit you will have this much resistance. This is actually 15 volt. All right. So what will be the current in the circuit? First you have to see. Okay, you have to see the current. So the current will be voltage by the resistance, right? This is kilo ohm. Okay, 10 to the power 3. So this is the current, maximum current I0 in the circuit. This I can write as 10 to the power minus 3 so that I get milliampere. So 100 milliampere, right? Or let us ten. Okay, so this there will be 100 and I'm sorry, this is 0.1 actually, 1 over 10, so 0.1 ampere. So this is the current initially. Now see, at t is equal to 0, K1 is opened, so this is open now. Now this thing is, so after a long time, the LR circuit, the circuit has got some now current, some current. So I have got the maximum current 0.1 ampere. This much current is flowing in the circuit. Now suddenly this is opened and it is closed. Now look, in this circuit the maximum current is this. Now the battery is switched off. So what will happen? There will be discharge or decay of current in the LR circuit. So here you look, now this L will act, okay, because you know the battery is not giving any support now. So what will happen? Whatever current was flowing, that will actually decay through the inductor and the resistor. Okay. So what is the, so this is L and this is R. Okay, current was flowing, that is I0 is the maximum current. Now you have to find out what is the current after some time. So you know this is instantaneous current, in this is actually written as while decaying the current, not growing the current. While decaying the current, the expression for the current is this T by tau. Okay, E is equal to I0, sorry, I is equal to I0 e to the power minus T by tau. Okay, that is the expression while decaying, when the current is decaying, right? So where I0 is given here, this much value, and what is tau we have to find out. In case of tau, say in case of inductor, tau is L by R. Okay, tau is L by R, that we have to find out. So L is given as 0.03 Henry, and what is R? R in the this kilo ohm. Okay, so that means this is C over 100. This is 15. Okay, so this is kilo ohm, this is Henry. Fine. So this will actually give you, this is 5, 10 to the power minus 2. This is, okay, another, so this is 100. This is, so there will be 10 to the power minus 3. Okay, no, this will not be there. Fine. So you will get actually 1 over 500. Did I write this correctly? I have to just check once. No, I'm sorry. This is actually 0.1. That's why the value will be different. Okay, so just a minute. Here it is this one. Then what you will get. This is 3 divided by 100 into 150. So this is 550. Okay, so tau is in second. Actually, this is in second. That means you get 1 over 5 into 10 to the power minus 3. Okay, this is actually millisecond. 1 over 5 millisecond. ms 1 over 5 ms. All right. So now if we just put it here, I don't know whether I have space. Yes, I have space here. Look. So I is equal to I0 e to the power minus t by tau. So t is given 1 millisecond. That means 10 to the power minus 3 second. And tau we have got something. So this is 0.1 ampere into e to the power. T is 10 to the power minus 3 second. And here it is tau is 1 over 5 into 10 to the power minus 3. 10 to the minus 3 minus 3 goes off. E to the power, just 1 minute. 1 over 5. We're going right. 10 to the minus 3, that is fine. So 1 over 5 millisecond, that is also fine. Okay, so here it is 10 to the power minus 3. 1 millisecond, t is equal to 1 millisecond, that is also fine. So both are cancelled, and you get actually e to the power. So this is this is 0.1 ampere into e to the power minus 5. So e to the power minus 5, in the question it is given. See, in the question you are given e to the power 5 is equal to 150. So e to the power minus 5 means what we can do, we can write this much ampere into e to the power 5 whole to the power minus 1. That means you get this ampere into 10 to the power, see, 150 whole to the power minus 1. That means, so 1 over 1500. This is ampere. So if I multiply 1000 to make it milliampere, Okay, 5 2 is 10, 5 3. Okay, so 2 I have to divide with, sorry, 3. Again 2, so 6 6 6, like that it will come. So it will be around 0.67 milliampere. So this is milliampere. I hope students you have understood this. If not, I'll just recap once again. See here actually what was the question? Question was that initially the ALR series circuit was connected to the battery just by keeping this K1 closed for a long time. That means the circuit has attained a maximum current, right? Maximum current, and that maximum current I have already found out. What was that? That was I0 is equal to 0.1 ampere. How do I do that? See, I have found out from here 15 volt, and the effective resistance in this uh, series circuit, since it is actually DC case, after a long time the current will be fixed. Okay, after some time current will be fixed in the circuit, and when there is no change in the current, so there will be no effective resistance from the uh, inductor coil, so it will act as a conducting path. So that is what is the fundamental idea. So I'll have only resistance due to this, like resistance due to this resistor itself. So I have just put it here, and then I had just calculated the current, maximum current that could flow in the LR circuit when K1 is closed for a long time. So that is actually 0.1 ampere which I got, and then I then see simultaneously this K1 is open and K2 is closed. That means now L and R has a maximum current in the circuit, and that current is actually decaying through, like decaying. Now see, battery is disconnected and this circuit is actually closed. Now the effective like circuit is this, actually decay of current. Okay, what is happening is decaying of current decaying of current, and that has got an equation like this. We have already discussed this. So I is equal to I of t at any instant of time. What will be the current in the circuit? So that will be I0 e to the power minus t by tau. This is also an exponential case. Okay, so exponentially the current will die out. All right, so now tau is the time constant, that is actually L by R for LR circuit, and from there I can find out what is tau for the circuit, time constant for the circuit. So I have got so far time constant, and I have got I0, and C t is given 1 millisecond. So what will be the current in the circuit? So we had to put the tau value and t value here. Since I0 is known, then things will be done. So this will be actually 0.67 milliampere. The current will be 0.67 milliampere. Okay, so I have got another problem. This is again an interesting problem. This is also kind of LR circuit only. See here in the circuit shown, as well this question is JEE Main 2014. The previous questions are actually one was from 13. So this one is actually JEE 15 JEE Main 15. Okay, let us now see what is the next problem. The next problem is this one. In this question, what is given? In the circuit shown here, the point C is kept connected to point A till the current flowing through the circuit become constant. Okay, so similar problem actually. See, if this is given, some voltage V is given, So the current will be, since it is DC, current will be constant after some time in the circuit, and then the total current will be actually I0 is equal to V by R or V0 by R, whatever given the amplitude of the, or sorry, maximum. Here there is no V0 business because this is DC, so this voltage will be constant voltage. Let us say that is V. Let us say that is V. Okay. So what it was done actually, say until the current becomes constant in the circuit, A and C were connected together. Now as soon as the current has become constant, suddenly what happens? Suddenly this B is connected, C is actually disconnected from A and connected to the point B at a time. Okay, the ratio of the voltage across the resistance and the inductor at T is equal to tau, T is equal to L by R will be equal to what? You have to find out. See, you have to find out the V R by VL is equal to what? So there are options here, E by 1 minus E, then 1 minus 1, 1 minus E divided by E. So these are the options. See here, one thing is very, very clear, that when the battery was connected, thing is clear now. When the C is disconnected from A and connected to B, now it is actually again LR circuit. LR circuit. Current is actually decaying current. Okay, here also some maximum current has been attained. Now current is decaying. Okay, in this decaying, current is decaying. So you know this the total voltage here now, since, so okay, let us do one thing, apply Kirchhoff's law. So Kirchhoff's law says VL plus, this is actually VR here and VL here. So this is actually after disconnecting of the battery, this will be 0 then. Okay, so it is actually very simple. This is the trick. The VL plus VR is equal to 0 by Kirchhoff's law. By Kirchhoff's law. So we have to find out the ratio of voltage across resistance to the inductor. This will be -1 only. So this is the answer, option C. Now we'll just see one more problem. This is not problem, this is actually a question. The question is, the AC voltage across the resistance across the resistance can be measured using a option A, hot wire voltmeter. Second option is moving coil galvanometer, option C is potential coil galvanometer, moving magnet galvanometer. Okay, so these are options. You have to find out the answer for this. So, you know, this in case of AC, moving coil galvanometer may not be applicable. This will not be applicable. Moving as the potential coil galvanometer also will not be applicable. Moving magnet also will be not applicable. Only the hot wire voltmeter will be applicable. Okay, to measure the voltage across a resistor. Okay, now next question we will be discussing. So an ideal coil of 10, an ideal coil of 10 Henry is connected in series with a resistance of 5 ohm and a battery of 5 volt. 2 seconds after the connection is made, the current flowing in the amperes, the current flowing in amperes, you have to find out in amperes in the circuit. Options are: option A is 1 minus e to the power minus 1, option B is 1 minus e to the power 1 minus e, option C is only e, option D is e to the power minus 1. So ideal, this in series with a resistor. Okay, that means LR circuit, LR circuit. L is this 10 Henry and this is R is 5 ohm. It is connected with the battery, DC battery. This chapter is named as alternating current, but most of the problems are from DC. Okay, so we have to be careful. We have to solve many problems from this DC circuit as well to get a nice practice. Okay, so battery is 5 volt given. After 2 seconds, that means this is LR circuit, right? So in LR circuit, growth in current you have to find out. What is the expression? Expression is I is equal to I0 to the I0 1 minus e to the power 1 minus e to the power minus t by tau. Okay, so where tau is L by R in case of LR series circuit. Okay, so the question is t is equal to 2 seconds, and what is tau then? We have to find out what is tau. Tau is this, so L is actually 5 and 10 Henry and 10 Henry, right? And 10 Henry, and resistance is actually 5 ohm. So this will give you equation of 10. So this is actually 2 seconds. So the current is I is equal to I0 e to the power 1 minus t by tau. Okay, so this is the thing. Now t is equal to 2 seconds. Now we have to find out what is I0. So I0 will be V by R. For a long time behavior you have to see, so that the maximum current in the circuit will be, so V by R. V is 5 volt and R is also 5 ohm. So I0 will be actually 1 only. This is 1 minus e to the power. This is again 2 seconds. So t is actually 2 seconds. T is 2 seconds, and this is also 2. So what we get is this 1 minus e to the power minus 1. 1 minus e to the power minus 1. So option A will be the correct answer for this question. Okay, option A will be the correct answer for this question. So this is how we need to find out problem. Let me at least take one question which is really of AC circuits. Okay, these are all DC circuits whatever I have discussed today. So let me just take one question. This is actually JEE Mains 18. So for n, this is question number 6. For an RLC circuit driven with a voltage of amplitude Vm and frequency is given. Frequency omega 0 is given 1 over root over LC. That means you have understood what is this frequency. The current exhibits resonance. Current exhibits resonance. Okay. The frequency, the quality factor Q, the quality factor we have discussed yesterday only. The quality factor Q is given by option A, Q is equal to omega 0 L by R. Option B is omega 0 R by L. Option C is R by omega 0 C, and option D is CR this. Okay, so how to solve this question? This actually you should remember this various type of equations related to quality factor. So quality factor, we know Q is equal to omega 0, that is the resonant like frequency at which the resonance occur, and the band was 2 delta omega. Okay, and 2 delta omega we have seen R by L. So omega 0 L by R. This is actually the expression, and this is given in the first equation. Okay, so this is the answer for this question. So this was actually the question from JEE Main 2018. So we have to remember the expression for the quality factor. Okay, JEE Main 2018. Okay, so all right, I will stop it here for today. Next day we'll just study about the transformers and related numerical problems and remaining things from this alternating current chapter. So thank you for your patience. Bye for today.